move on from oil. We
Yeah.
need to move on from coal,
Mm-hmm.
right?
Mm-hmm.
And there's a bunch of like renewable energy sources we can use, like let's say power,
Yeah.
like wind power, hydropower, right?
Mm-hmm.
But the issue with those like types of issue with those with these is that it's not reliable,
Yeah.
right? Let's say one day you have clouds
Yeah.
for solar. It's
Yeah.
not gonna work.
Yeah.
We don't have enough batteries to actually
Mhm.
store all that power.
Yeah.
And like, or let's say like there's no wind one day. So
Yeah.
how is the windmill gonna work?
And if wind is in a certain direction.
Yeah. And
There was a windmill that I saw. It's a new concept windmill. Where it's just like a straight pole that
Yeah.
goes up, and you know how flagpoles dangle in the wind,
Yeah.
right? It's that same concept, right? It has no blades. They just dangle in the wind, right?
Damn.
And that dangling, that kinetic energy, right? They use it. They harness it, right? And that solves the problem of whichever direction the wind is. It has to be in that certain direction of a wind turbine, and that's an
Yeah.
ingenious solution. They just put a lot of them in the field. It's like huge antennae, and they just keep vibrating
Yeah.
in any direction. And
see,
it
that's
produces
innovation is
energy.
the key.
Innovation is
right?
the key.
Yeah. And this is the last one. Like, I think it's a really, really good like temporary solution.
Yeah.
But a lot of people disagree with this, and that's
What is it?
nuclear power.
Nuclear, what's it called? Is nuclear fusion at like a compact level?
Fusion
right now
is
theoretical.
we can't do fusion right now.
Yeah, that's what I'm saying.
There's only two. There's ITER. You know ITER?
The one in what is it, Sweden?
I think yeah. Well, no, it's not. It's somewhere like in Europe. I forgot where it is, but like there's one. Everyone's working on
I know
it.
about CERN. CERN's a particle accelerator, and they're doing a lot of.
CERN's in Bern,
Switzerland. Yeah. And I know that like right now, because right now the goal is to because right now fusion it's very inefficient. It takes in more energy than it gives out.
Yeah.
So the goal right now is to first of all solve that problem,
Yeah.
and second of all make it more compact.
Yeah.
So you know Lockheed Martin, right? The aerospace company. They have a concept, right? A future prototype of a fusion reactor that is like the size of a semi truck, which is a huge upgrade on size. Like it's way more smaller now, right? So the goal is not only to like make it efficient, but to make it smaller, so you can use it. And that's the main key right now. With like, I feel like if we achieve that compact, efficient fusion, like we're in the future. Like the amount of technology that can be made from it, like an Iron Man suit would be a real possibility.
Well, okay. When you talk about fusion,
Yeah.
we're not there yet. Simply, right?
Yeah, we're not. That's what I'm saying.
Because right now we can actually do fusion on Earth,
Yeah,
but
yeah.
it takes more energy, like you said, than it gives out, right?
Yeah.
So even like it's an unproven idea.
Yeah.
So you like even like let's say 100 years from now, right?
Yeah.
You can say for sure that fusion is gonna be viable,
Yeah.
right? You cannot tell me that okay, 100 years from now, like we're gonna be able to provide fusion energy to everyone.
Yeah. It's not sustainable.
Yeah.
Right now. We have
Well,
no guarantee that it is. Right
Yeah,
now.
because you don't know how much it's gonna take to like get it done.
Yeah,
you know?
exactly,
it might
yeah.
take so much money that it's not never gonna be feasible.
Yeah.
Right?
True.
So yeah, we're gonna put that on the side for a bit. We're gonna talk about fission right now.
Yeah.
So because that's what we have right now,
That's
right?
what
We have
that's what's
fission.
used. Yeah.
Yeah, well, that's basically you have there's like different types of fuel. There's like plutonium. There's uranium, right?
Yeah.
So 237, right? That's the one that's fissionable. Yeah. So yeah, you basically just hit it with a neutron, and it just splits, and energy is released, right?
Mm-hmm.
And that energy is used to like spin a turbine. No, it's actually used to
Heat
like
up,
boil the water.
Heat up water.
Yeah, and
Turns to
that
vapor, which
steam
spins
is
the turbine.
turns the turbine, right?
Yeah.
Now it says it has very very like low amounts of carbon emission.
Mhm.
I don't even think it's carbon emission. It's just like
No,
toxic.
it's just the main issue with that is like
the waste.
Yeah, the waste, radioactive waste,
Yeah.
and how to dispose of it properly. And in the case of disasters, right, like where like they blow up or
Yeah.
something bad happens, right? That is a very bad, because at that point it's like a huge bomb.
Yeah. See, that's one thing about fusion.
Yeah.
That fusion is not a bomb because fusion is just like all you have is just
And fusion
plasma.
is clean. It's
Yeah.
clean.
It's clean. You have
Yeah.
plasma,
Yeah.
and you basically just use magnetic fields to just
Yeah.
combine it together.
Yeah.
Incredibly high temperatures.
Yeah.
But let's say there's a failure, right?
Yeah.
All that's gonna happen is plasma is gonna cool down,
Yeah.
and reaction is gonna stop.
Yeah.
But like, let's say you do something with like nuclear
And
fission,
they're
right?
not radioactive at
Yeah.
all. There's no radioactive waste here.
There is because it
in
uses
fusion?
because it uses deuterium and tritium, right?
Yeah, but
Which
you
are-
have like, but you comparing that with like uranium.
Yeah, no,
it's
uranium
completely
is
different
way
levels. Yeah, that's what
because
I'm
with
talking about.
uranium, because they use like like what are they called?
They use rods.
rods, yeah.
They use rods.
And once they're done, like once the energy's out,
Yeah.
they stay radioactive. They emit heat,
Yeah.
so you can't store them in like a just
Yeah.
like a box
Mhm.
because there's gonna be a point where it's just gonna blow up.
Yeah.
Because they're gonna get so hot, they're gonna blow up. right? So that's why they're always like stored in like a cool place, like let's say water. So, like you said, like it's not sustainable in the long term, and that's why I said I think nuclear fission, it's like a temporary solution. So what we can do, we can just like start building more reactors, small, because technology is improving, right? Like, of course, we can build more safe, smaller reactors everywhere until we figure out like a long-term solution, which would probably be like fusion, or it would just be like improved hydro, solar, all that, like bigger batteries. But right now, we need to take action, and we need to step away from hydrocarbons. What's happening right now, actually, like France and Germany, like other countries, are shutting down their nuclear reactors. And the amount of energy that they used to produce before, that energy is going to be replaced by more coal, more oil, right? Which is, again, like, it's stupid.
Yeah, because why are they doing that? Are people concerned about the safety?
Yeah, that's the thing. That's one thing. Like, there's such a huge misconception about like nuclear fission reactors. Because when you compare the fatalities, right? Nuclear disasters. Okay, let's just call it Chernobyl, right? The most pessimistic, the numbers that come up, the amount of deaths that were caused directly by radiation from Chernobyl. 60,000 people. That's the most pessimistic, right? From the Green Party. Now there's a bunch of other studies, right? Like there's a study from like the Atomic Research or something, right? They said there's only like 3,000 like directly related deaths from Chernobyl. Which, when you compare that to coal, you compare that to like anything else like oil. It's nothing. There's like hundreds of thousands of deaths every year because of like coal, oil. Because you know what that does? Like it goes into the air and then it causes like
it's
a bunch
toxic.
It's
definitely more toxic for you.
So when you compare like 3,000 deaths from Chernobyl to like all this,
there's more in nuclear power plants. There's way more precaution taken.
There's like a bunch of regulations that have to follow.
Way they're way better there.
Especially like after we had like two like big disasters, the Fukushima and the Chernobyl. So after that we've learned. So I just don't see like why we're moving away from nuclear back to coal.
There's definitely, I feel like the solution to this would be to educate people more. Right? To try to get more out there, which is why like these science programs and all these programs, especially for the youth, are very important. People get educated, right? And but I still do understand people's because after two huge disasters like that, right? Obviously, there's people that are still kind of worried about it, but they shouldn't be, because I think they shouldn't be. That's my opinion, especially because of how far we've come and the precautions we take right now, and like you said, looking at statistics, right? If you look at all of that, right, then it is relatively safer, and it's a better option.
It's a cleaner option.
Granted
that there's nuclear waste, but there's ways to deal with it, right? We're not saying that you have to use them for like, because we can't even use nuclear reactors, like fission reactors, for a very long time. Because what's it called? We don't have enough uranium
in the earth.
So like in 100 years, we're gonna run out of uranium.
So we have to figure out something fast. We have to.
But it's a really good like potential solution, and I think we should think about that. Well, okay. I think that's it for today. I hope you guys enjoyed it.
Night talks.
And we'll see you guys on the next episode. Take care.